Welcome back to part 2 of Module 6, Lesson 4, One-Step Multiplication Equations. We're going to start this lesson out with a video from our sponsors.
Use algebra tiles to solve one-step multiplication equations. Find the value of x for the equation 4x equals 12. Model the equation using algebra tiles. Place 4x tiles on the left side of the mat. Place 12 1 tiles on the right side of the mat. Arrange the tiles into even groups on each side of the mat. For each x tile, there are 3 1 tiles. So, x equals 3. Let's try another example. Find the value of x for the equation 18 equals 3x. To model the equation, place 18 1 tiles on the left side of the mat. Next, place 3 x tiles on the right side of the mat. Arrange the tiles into even groups on each side of the mat. For each x tile, there are 6 1 tiles. So, x equals 6.
And while that is a great visual representation, of course that's not showing big kid math. I'm not sure if you can hear the strange noises my cat's making in the background, but she's having some issues. As I was saying, this is not using the big kid math, and we will be using big kid math when we work on these problems in class. And that leads us directly into the division property of equality. The textbook says to solve a multiplication equation, use the inverse operation, which is division. When you solve a multiplication equation by dividing each side of the equation by the same non-zero number, you're going to be using the division property of equality. Looking at it at words, it says, if you divide each side of an equation by the same non-zero number, the two sides remain equal. That's your definition for your vocab quiz. And under examples, we've got if you had 9 equals 9 and you divide both sides by 3, then you get 3 equals 3. If you have 4x equals 8 and you divide both sides by 4, that means x equals 8, and x was always equal to 8. Pretty easy stuff, don't you think about it? Very similar to when we were doing the addition and subtraction, only now we're using multiplication and division. So let's apply this to an actual problem. Here we have 2x is equal to 10, and that's what they want us to solve. And we're going to be using the division property of an equality. As you go into this, I want you to be asking yourself questions like, what's my variable, who's my friend, and so on. Oh, well, wait a minute. They want us to use the tiles first, so we're going to take and use that method first. That means we're going to need to drag, where's these? Ah, there they are. Okay, so we're going to start off by dragging 2x tiles to the left of the mat to represent 2x. So I got 1, and I've got 2. And then we're going to take and drag 10 algebra tiles to the right side to represent 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And then from there, the next thing they want us to do is to group one tile on the right side into 2 groups. And so that there are 2 x tiles on the left. Yeah, okay, so we're going to take and break it down here and break it up there. And we'll go 1 to the top and 1 to the bottom and 2 to the top and 2 to the bottom, 3 to the top and 3 to the bottom, 4 to the top and 4 to the bottom, 5 to the top and 5 to the bottom. And so what does x equal? X is equal to 5, because each one of these x's, that x lines up with 5 and this x lines up with 5, so x equals 5 is your answer. Yeah, that's all nice and pretty and stuff, but it sure would be nice if we had something that was a whole lot simpler to do on paper, like algebra. Yeah, algebra's cool. So now we get to use that division property of an equality, where we acknowledge the fact, what's our variable? X. Who's his friend? 2. And what is 2 doing to x? It's multiplying. What's the opposite of times 2? It's divided by 2, and if you do it on the left, you have to do it on the right. So right there you can see they divided both sides by 2. If it was me, I'd draw a line, or better yet, a 1 through here, saying 2 divided by 2 is 1, and that leaves 1 times x is x. 10 divided by 2 is 5. Check your answer. I'm sure y'all can hear the annoying cat now. Well, come here. I don't care. And that's going to be your final answer. So you can say that your solution to the equation 2x equals 10. Come here, you annoying thing. Oh, this is what you hear screaming at you. 2x equals 10. Well, that means that x is equal to 5. This is showing your work. This is what I must see. And if I see anything else on each and every problem of your homework, you've done it just for fun. Go ahead and pause the video and work extra example on your on your own, making sure you're showing good, high-quality supporting work just like I showed you, and then check your answer to see if you get it right. Alright, Noisy Cat got down again, so now we can work a problem on our own here. We're going to take and start off by using the division property of equality. We have xt as our friend. His variable is 27. 27 is multiplying itself times t, so we're going to divide by 27 on both sides. Whoops, that should be, there you go, 27, there you go. 27 divided by 27 is 1. 1 times t is t. And then 35 divided by 27, oh, that's going to end up being 5. I do believe, let's see, 5 times 20 is going to be 100. 5 times 7 is 35. Yep, that's going to be 5. So t equals 5 is our answer, just like it was on the last one, I do believe. Plug in your answer, hit check, and the answer checks. Going back to our work, this is showing your work. This is what I must see. If I see anything else on each and every problem of your homework, you will have done it just for fun. But what if we had fractions involved in all this? How are we going to solve that? Let's take a look at 2/3 m is equal to 5/8. Now, I really don't like the way your textbook shows these, because what they're going to tell you to do is to isolate your variable by dividing both sides by 2/3. I'm totally cool with that, but watch this. They're going to do it vertically. And fractions inside of fractions is a horrifying thing to look at. So I'm going to go and do it off to the side my own way, which is going to look a little different. I've told you before that when working fractions, it's a lot better to do them horizontally. So I'm going to do 2/3 divided by 2/3 times m is equal to 5/8 divided by 2/3. The only thing that has changed is I've divided by 2/3 here, and I've divided by 2/3 here. Everything else stayed the same. 2/3 m equals 5/8. We're just taking and rewriting the problem so we can work it horizontally. Now from there, I can take and say 2/3 divided by 2/3, that's going to equal to a 1. And a 1 times m, that's going to be m. And then on the right, how do we work fractions? Well, we're going to keep the first number, we're going to change division and multiplication, and we're going to flip or take the reciprocal of the second number. After that, we're going to simplify if we can, which we can't. 5 times 3, that's going to become 15. 8 times 2, that's going to become 16. So the answer is going to be m is equal to 15/16. And if you follow through what they did, and now they're going to do their keep, change, flip horizontally, doesn't make a lot of sense to do it that way. Do it my way, it's better. 15/16, accept and check, and the answer checks. From here, you're going to get to work the next problem on your own. Extra example 3, I want you to use my method, the horizontal method, when you're solving this. It's better for fractions. It makes it a lot less confusing. So go ahead and pause the video. Oh wait, no, this is decimals. That means you're going to have some very unfriendly grunt work off to the side. Pause the video and work on it now. Alright, this time I have those set off to the side a little bit because I'm going to need some space to do some very unfriendly grunt work. So, the final goal of an equation, isolate your variable. What's your variable? It's g. Who's g's friend? It is 11.7. And what is 11.7 doing to g? It's multiplying. How to undo times 11.7? By dividing 11.7 on both sides. This one here divides out becoming 1. 1 times g is g. And then over here, we're going to take the first number and put it in the house, 85.527. And outside the house, we're going to have the 11.7. Then we're going to take and bounce the decimal outside the house until it hits the wall. Bounce the decimal inside the house, the same number of spaces to the right, and then move it up. Now we got to figure out how many times is 117 going to go into 855. Let me think. 5 or 8 times 7, and it has to be 7. So we're going to take and start off with the 7 right here, and that's going to give me a 49. That's going to give me a 7 plus 4 is going to be an 11, and then that's going to give me a 7 plus 1 is going to be an 8. We subtract that out. There's going to be some borrowing going on here. 15 minus 9 is going to be 6, and 4 minus 1 is going to be 3, and then this 2 is going to come down. Should work into that number 3 times, I believe. 3 times 7 is 21, and then 3 times 1 is 3, plus 2 is going to be 5, and then 3 times 1 is going to be 3. Yep, subtract that out. We get 11 left over, and oh, how pretty this one's going to come out. Bring out that 17. 1 times 117 is 117 with nothing left over. So our answer is going to be 7 and 31/100ths. Jump back over here to where we can put it in, and put in our 7.31. Hit check, and the answer checks. Not hard work as far as the isolating the variable goes, but that one did have some pretty unfriendly grunt work. As always, this is showing your work. This is what I must see. If I see anything else on each and every problem of your homework, you will have done it just for fun. Alright, that's going to be it for this lesson. Get busy doing your homework assignment. Make sure you're showing me good, high-quality supporting work so I can give you good, high-quality credit for doing it. I'll see you in class tomorrow.